In permission blockchain networks, the hardest problems aren't about the ledger. They're about people and institutions. Who's allowed to join, what can they do, and who keeps them accountable? In this module, we'll treat identity, membership, and governance as first-class architectural components and design them as deliberately as the technology. Public blockchains optimize for openness. Anyone can join, identities are fuzzy, and finality is probabilistic. That's fine when you're moving internet tokens, but it clashes with enterprise and government expectations for clear accountability and predictable outcomes. Permission networks flip that model. Participants are known, vetted entities. Every node is tied to an organization, every action to a cryptographic identity, and behavior is constrained by contracts and policies. You're moving from whoever shows up can write to only identified parties can act, and they're accountable for what they commit. When you design blockchain-based trust, always separate the organization from the node it operates. The legal entity is the true actor. It signs agreements, owns assets, and carries liability. The node is infrastructure. It runs software, stores data, and participates in consensus. In permission networks, you'll usually see several node roles. Validators write and agree on new blocks. Observers provide RAID-only access for internal systems or partners. Auditor nodes focus on oversight and evidence collection. Architecturally, map legal accountability to entities and operational behavior to nodes, and keep those layers distinct in your design. Membership service providers are the gatekeepers of permission networks. Their job is to take a real-world organization or user and turn that into a cryptographic identity the ledger can verify. They typically rely on X509 certificates and your existing PKI, so they integrate directly with enterprise and government identity systems. The MSP decides which certificates are valid, which roles they map to, and therefore what each participant is allowed to do on the network. Functionally, it's the digital passport office that the consensus layer trusts for every transaction. Here we're connecting existing enterprise identity to the blockchain world, instead of inventing a new silo. Treat your corporate SSO and directory as the source of truth. A user authenticates there as usual, and an identity bridge issues a token or key material to the blockchain network. That bridge maps IAM roles and groups to wallet keys and smart contract permissions, so least privilege remains aligned with your existing policies. The real payoff is lifecycle control. When HR disables an account, the corresponding blockchain identities and keys lose access immediately, without separate manual cleanup. Public key infrastructure is the cryptographic backbone of a permissioned blockchain network. At the top sits a root certificate authority, chosen and governed by the consortium. This is your ultimate trust anchor. The root's private key should live in a hardware security module so that even insiders can't easily extract or misuse it. Below the root, intermediate CAs issue certificates to organizations, nodes, and end users. Architecturally, the critical piece is lifecycle discipline. Well-defined processes to generate keys, rotate them regularly, revoke them quickly, and distribute updated trust lists across all participants. Decentralized identifiers and verifiable credentials give you an identity layer that isn't owned by any single organization. A DID is a stable, globally unique identifier whose root of trust is anchored on a ledger, while the personal or organizational data remains off-chain. Verifiable credentials are digitally signed claims bound to those DIDs, a license, a role, a security clearance. Because any compliant network can verify the same cryptographic proof, a user can present one credential across multiple enterprises or agencies, avoiding re-onboarding while still letting each domain enforce its own policies. Blockchain does not remove the need for human decision makers. It just changes what they decide about. You still need a structure that answers questions like, who sets strategy and budget? Who can change protocols? Who owns liability when something goes wrong? A useful mental model is a three-pillar board. A steering group handles strategy, funding, and legal mandates. A technical group owns protocols, upgrades, and standards. A risk and compliance group owns audit, controls, and data protection. All of this rests on a formal consortium charter or memorandum of understanding that every member signs and can be held to. For a blockchain consortium, the real foundation isn't the software, it's the legal wrapper around it. Memoranda of understanding and consortium agreements define who is allowed in, who does what, and who is liable when something breaks. They also set rules for identity issuance, what data can live on-chain versus off-chain, and how disputes are resolved. The code enforces rules technically. The agreement makes those rules enforceable in law. When an organization joins a permission network, it goes through a life cycle, not a single approval. First comes the legal track: consortium agreements, data sharing terms, liability, and jurisdiction are agreed and signed. This defines who can do what and under which law. Next is technical provisioning. Membership and node identities are issued, endpoints are configured, and connectivity and monitoring are verified. Finally, role accreditation ensures the organization only operates in approved roles after security due diligence and, in some cases, audits. Treat this lifecycle as a control surface. Each step enforces a different aspect of trust. In a regulated blockchain network, upgrades should feel boring and predictable. Everything starts with a formal change proposal, not a code push. That proposal goes through impact assessment, security, performance, legal, and interoperability. Only then do members vote through the agreed governance process. If it fails, the change is rejected or reworked, not silently deployed. If it passes, you schedule a time-locked deployment so every organization can prepare. Versioning rules and rollout steps are coordinated across all nodes to prevent forks and inconsistent behavior during the upgrade. In any permission network, you need a reliable kill switch for misbehaving or exiting participants. Think of it as a tightly scripted playbook. First, revoke trust at the cryptographic layer by publishing updated certificate revocation lists so their keys instantly fail. Second, offboard them operationally. Remove their identities and roles from access control lists, automate node disablement, and close any integration endpoints. Third, handle their data according to policy and law. Retention, anonymization, or effective deletion to satisfy GDPR and similar regimes. In a shared blockchain network, incident response is only as strong as the weakest participant. You want monitoring that correlates logs across organizations, so anomalies that look benign locally stand out globally. Then define joint playbooks. Decide in advance who the incident commanders are, how they contact each other, and what evidence must be preserved from the ledger and from off-chain systems. Finally, agree on emergency operations. When a node must be isolated, who can trigger that, how keys are handled, and how you safely bring the participant back online. For any permission network, think in terms of three inseparable pillars. First, identity. Keys must be tied to real organizations and people through PKI and your existing IAM. Second, governance. Define who decides what, and capture that in decision bodies and formal agreements. Third, operations. Automate onboarding, key rotation, and revocation. Robust designs keep all three in sync, end to end. Before you move on, translate this into your own environment. Start by mapping today's IAM stack to a permission network. Who issues identities, who approves access, and how would those roles change when multiple organizations share a ledger? Capture concrete deltas, new approval flows, new audit data, new key management responsibilities. Then review your existing governance charter. Does it define who can run validator nodes, change consensus parameters, or retire organizations? Note these gaps. They become inputs to your target architecture and roadmap.